6.1. Law of sines. I'm recording this. First thing is the definition of an oblique triangle. What's an oblique triangle? It is a triangle that does not have a right angle. That's all it is. It's just a triangle that doesn't have a right angle. So then my question is, how can I use trig on an oblique triangle? Because aren't I supposed to use sine, cosine, tangent, secant, cosecant, and cotangent on right triangles only? Only. That's what Mr. Otteson told you back in honors geometry, right? But on oblique triangles, I can use trig functions. I just have to use law of sines or law of cosines. That's what I can use on a oblique triangle. So I'm still applying some trig to that. So I'm just going to give away what law of sines is first. Law of sines for some oblique triangle. You see there's no little box that shows you it's a right triangle because it's not. It's oblique. In law of sines and law of cosines, which is 6.1 and 6.2, and then we'll take a test after that, I'm going to draw a triangle like this every time. This is one place I don't try to draw the triangle accurate. When I taught geometry, I would usually try to, if it was supposed to be an 82-degree angle, I would try to draw a triangle with an 82-degree angle. Here I do not. I'm going to draw a triangle like this every time, or like this, kind of bent over here or bent over here. But I'm always going to go A, B, C, capital. You must do that. You must do that. And then across from angle A is side A. Then we use a lowercase. Across from angle B is lowercase side B. Across from angle C, which is capital, that side is going to be a lowercase c. You have to write that correctly so that you can follow this. You don't do this correct, this makes no sense to you. These three ratios are equal to one another. So I can say these two are equal to each other, or these two are equal to each other, or these two are equal to each other. Sine of angle A over side A equals sine of angle B over side B equals sine of angle C over C. And so, side C. And so these are across from each other. That's law of sines. That's what I get to use. So I get to use some trig, very particular kind of trig, law of sines, on an oblique triangle. To do what? Well, what we're going to be doing is solving the triangle. What is solving the triangle? And yes, it's going to feel like I'm back in a geometry class for 6.1 and 6.2. That means to find all of the side lengths and all of the angle measurements. So in other words, I want to know what this is, and 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 this is. Everything. How am I going to do that? I'm going to use law of sines to do that. Or law of cosines. Or whatever else in your past. I just must find all those sides. May I change this sheet? Anybody not ready, just raise your hand. Awesome. So the first thing I must do is I must prove to you that this is true, and I just didn't pull it out of the air. So I'm going to do that to you first. I'm going to prove this. Because this is kind of like what Mr. Otteson did on that Friday when I wasn't here that one day. He came in here and he proved the difference of cosine alpha minus beta. He came in here and did that derivation all day long. I'm going to do a derivation, but I'm going to do it very short. So there is some oblique triangle. I did the same thing, capital A, capital B, capital C, and I did all the sides appropriately. And what I want to do is I want to show you where this came from. So let's go ahead and let's draw in a height. We'll call that H. So let's go ahead and do some sine on this, because now I actually have some right triangles in here. I have a right triangle here and I have a right triangle here. So I'm going to do sine of this. I'm going to push that up just a little bit. So sine of angle A, that's opposite over hypotenuse. Now I'm going to come over here and I'm going to do sine of angle C. That's opposite over hypotenuse. Do you agree with me so far? Now, I'm going to go ahead, because I'm coming all from the same triangle. Those h's, those heights are both the same. So I'm going to set those two equal to each other. So in order to do that, I must isolate the h. So I'm going to multiply, and I'm sorry to make that c so big. It's supposed to be a lowercase c. Lowercase c, right? Multiply both sides. They're both set equal to h. That means I can set these equal to each other. I'm going to divide by a. Divide by side c. So now I have proven that these two are equal to each other. The way I get the rest of it is I just repeat it. I'm going to move this up for a minute. I'll put the A here, the B here, the C here at the same height, and I repeat it. And then I put the A here, the B here, the C here, and then I just do the sign of each, isolate the H, set them equal to each other, and you'll eventually get that all three of these are equal to each other. So that's where law of sines comes from. Okay? So now that I've proved it to be true, I'm allowed to use it. Then let's begin. Let's solve my first triangle. Darn near what you're going to be doing the entire time. Solve the triangle. That means I need to find 3 angle measurements, 3 side measurements, and they're going to give me 3 pieces of information. So the first thing I like to do is I like to draw my oblique triangle, just like you will. You will draw your oblique triangles. That's 64 degrees. This is 82 degrees. And C is across from here. That is 14. I'm going to put my lowercase a and my lowercase b. I like to tell myself what I need to find. I need to find side A. I need to find side B. And I need to find the measure of angle C. So I'm 3 given, 3 unknown. Once I find these 3, I'm done. I have solved that triangle. Well, what can I solve? I can solve for one of those 3 right now, what you learned with Mr. Otteson. Yes?
Would it be the angle measurement of B?
B, sorry.
You can find that.
Sorry. Anyway, I can do what?
You can find B.
Why?
Because
Every triangle is always 180 degrees. I already know 2 of the angles. It's 64 and 82. So 64, 82, 6, 146. Subtract that from, you said, 180 degrees. So that would be 34 degrees. Because that is an exact answer, exact means there wasn't like a calculator and decimals that I cut off, right? And so I'm allowed to write it in my box, and I'm allowed to write equals. And I'm sorry, not allowed to write in the box. I'm going to write it in the box. It means I get to draw it on my picture. I only like putting exact answers if I can help it on here. That means I'm allowed to use these in my math problems. And that would be in equals. Next, I need to find side length A and B. Well, now here's where I'm going to have to use my law of sines and law of cosines. What you need to do, so you're going to use any 2 of these, maybe these 2, or these 2. And so let's say I use these 2, for example. In order to solve, I can only have one unknown. So only this can be unknown, I better know these. Or this has to be unknown, I better know these. So I better at least find one ratio, I know it, and then on the other one of them I know and one of them I don't know. So the first one I'm going to look for is for which one of these is filled in. So let's see. That one is not. That one is not. This one is. Isn't that ratio? So I'm going to write that one down first. Sine of angle C over side C. I write it generically first, just so I can practice that. And then it doesn't matter which one I go for, A or B. I'm just going to do A first because of alphabetical order. So I tell myself what I'm going to do. Now I'm going to go substitute. I know what this is, sine of 82 degrees. Side C is 14. This is sine of 64 degrees. And then this is the I don't know. I'm going to solve for A first. So all I have to do now is isolate the A. So that means I'm going to multiply both sides by A. And then I'm going to multiply by the reciprocal of this. Right, this goes on top and this goes on the bottom. And this is where you would take out your handy-dandy calculator. Should I have this in degrees or radians? Degrees. 64 sine times 14 divided by 82 sine. And you notice I put the approximate. I'm going to go ahead and go to, I think most of the directions say go to 2 decimal places. So my calculator reads 12.706. 2 decimal places means look at the third place to get the second place. That's approximately 12.71. Come back up here, change this to approximate 12.71. What is the only one I do not know? B. So again, I'm not going to write that here. That's an approximate, because if I use that in my next math equation, my answer is going to get worse. It's going to be not as accurate. I like exact answers to go into my calculator. So I'm going to leave that here, and I'm not allowed to use it. So the only one that is still complete or ratio is C. So I'm going to do sine of C over C, and now I'm looking for B, because I've already got A answered. I need to find B. So now it's sine of capital B over side B. So that's sine of 82 degrees over 14 equals sine of 34 degrees over side B. I'm going to isolate my B. So that goes up there. So that's 14 sine of 34 degrees sine of 82 degrees. And I'm going to go get that approximate answer. I went faster. I know you can handle that. And now I'm done. I have solved my oblique triangle. I have all the angles and all the sides. Do you have a question? Yes?
I didn't get that. I didn't read it. What was it about this? I got 7.9.
Ah.
7.91.
Good. Let me try it again. I did too. Thank you. So that brings up another thing is I don't trust my finger on a calculator. I only did it once. Typically I do it 2 or 3 times because I know I just don't hit the right buttons. May I change this? Do it again. So I'm supposed to solve this.
What is beautiful?
12. What can I find first? Yep. Do I have to find that first, or could I find A or C first? You have to find it first because right now there is not one complete ratio. If I use law of signs, there would be two unknowns. So now I'm going to go find side A and C. So which ratio is complete? The A's, the B's, or the C's? The B's. And it doesn't matter which one I do. I'm just going to do, again, alphabetical order. So if you want to write generic, please write generic again. I was kind of saying it in my head. I was telling myself, make sure I focus on B's, make sure I focus on A's. If you can't keep that focused in your head, you need to write that generically. Now I'm going to isolate my A. Is this what you got? I'm going to do it one more time this time. I got the same thing twice. So the only thing left is side C. So again, I only know B. I need to do C. There's a lot of room for error. Keep it straight. Write it generically if you have to first. Did you get approximately 5.12? Yes? No? That's what I got. Out of these three angles, which one's the smallest, A, B, or C? C. Do you remember in geometry? Across from the smallest angle is the smallest side. Across from the largest angle should be the largest side. And the middle angle should be the middle side length. Remember that? So like a mini check. See if you kind of did some things okay. Ask me a question. Or correct me. Yes?
I didn't get that. I got 5.18. Yeah,
Okay, so it takes you guys a while to answer me? Oh, I have 5.177. I don't know why I'm reading 2. You guys are too scared of you, thank you. Sure, if you want to miss this, go right ahead. Quickly. Next. Already, what's different? 2 sides, 1 angle. So can I already find that third side? No. See, I'm drawing my same triangle. I don't care about if I write it 57 and 30. I don't care about those things. So you're okay with what I wrote so far? Draw my triangle the same. I input in the information, and I tell myself what I'm supposed to find. Now I cannot first find the third angle because I only have 1. Okay. So I guess I proceed to the next thing. All I have is law signs today, because that is not a right triangle. I cannot just use sine, cosine, tan, any of those by themselves. I can only use law signs. So if I have to use law signs, that means I need at least 1 complete ratio. Is there a complete ratio there? Is it A, B, or C? A. So I guess I'm just going to start there. I'm just going to write it down. Sine of 57 degrees over 33. I'm just going to pick the B side, B's. Oh, I don't know the angle B. So sine of capital B over 26. That's still just one unknown, right? Mm-hmm. Except it's an angle this time instead of a side length. That's okay, just so there's one unknown. A little awkward, but that's okay. So let's at least isolate for sine of B, where that thing I don't know is. And I'm going to put that over here to the left side because I just like seeing my unknowns on the left. So make sure that you get what I did. I switched sides, and then I isolated sine of angle B. Now, how did we just do this in chapter 5? Inverse. Thank you so much. So that means I put sine, I write the inverse, and I switch out my x's and y's. So now this goes here. Let me see here. Sine, this is positive, so it's going to be in quadrant 1. So my answer needs to be quadrant 1 positive. Well, no, duh. I'm in a right triangle. A triangle. Everything's got to be positive. There's nothing negative in my oblique triangle, so my answer needs to be positive. Oh, okay. So let's pick up my handy-dandy calculator. Am I in radians now or still degrees? Still degrees. And let's round to the nearest whole degree. Yes? Okay. So that is approximate because I cut off some digits. Which other quadrant is sine positive? Oh. for that ratio, I could get 41 degrees, which is my legal answer with the inverse, but which other angle could it be? Which other angle could it be? And I still get positive. What other angle would give me that exact same answer? You told me it lives in which quadrant again? Okay. So what would that be? Right, let me see. 180 minus 41. Oh. I wonder if maybe I can make a second triangle. Let me take a peek. I'm going to take my sticky pad up here for a minute. This is 57. And we already said 41 is the answer. Of course that can be allowed. Of course, right? That's what, 98, so it's going to be, what is that going to be? 82. And then, again, I'm not trying to make accurate triangles, correct? I was given a 57. It could be for that same ratio. I mean, whatever that ratio is, it could be 139. Can that exist there? Why can't that exist? Why can't that be a second triangle with 139? Why can't it be? Oh, yeah. Okay. Thanks. That makes sense. And then I guess C must be approximately 82, right? Because I cut off some decimals from my 41. So that's still an approximate 82. I still need to find side C. What am I allowed to do?
Yeah, because you know how you said you needed like one of the ratio thing, at least one?
Yes, and so this one right here.
Yeah, but you don't want to fill in.
Are you talking about the next problem, the next part? Okay, you're ahead of me. I'm just seeing, make it go slow enough, and I look around to see if I see people like with question marks on their face. You're already ahead, as if I see everyone without it. And you're right, I don't think I see any question marks, so thank you. So let's go ahead and let's take a look at that. So I've kind of used my space here. I'm going to kind of cover that up so I can write here. So let's see. I need to find side C, right? I still have a complete ratio. Let me write that down. And I have to find this guy. I guess I have to use it, right? I have no choice.
You can't use B? Knowing that like B, your angle is 41. Can you use B now or it'll still be A?
Well, let's see. If I used B, okay, so right now, isn't this guy here already going to be approximate? Okay, so if I do B, that would be sine of 41 degrees over 26 over, I need to find, what do I have? I have sine of C over little c. C is what now? 82. So this guy is approximate and this guy is approximate, and I have to find you. I have to find you. One approximate means already my answer is not going to be as accurate. Now I have two approximates. I have to find you. Yuckola. No, we're not doing that. That's why I don't let myself, if I can, write approximates over here. So when I go to start writing my equation again, I grab from here. I still see only exact answers of sine of 57 degrees over 33. I know I have to find this. I am forced to grab out of here. Yes? And I'll do my check. It looks like my largest angle is C. So the largest side is 38, almost 39. That makes sense. My smallest angle is B, so the smallest side is 26, and so my middle angle, 57, between these two, 33 is between 38 and 26. Okay, I'm okay with it. Use a little bit of geometry there. Anything you'd like to ask? Do it again. This looks a lot like the last one we just did. I gave you one angle and two sides. Gosh darn, I'm going to have to do some inverse trig again. So let me draw my cute little triangle. Got myself set up and ready to go. So I guess I just need to start because I can't find the angles right now. I have a complete ratio of A's. So sine of 50 degrees over 10. Use the ratio of the A's. Oh, I don't know. Can I even do C's? No. I guess I better do B's. Let's do B's. Let's see. Sine of capital B, I don't know that angle, over 20. Oh, I see. I'm going to have to look for that angle. So let's isolate sine of B, and I'm going to throw it to the left. And then what I really want to solve for is B, so I need to do some inverse trig. So this is equal to B, but now once I throw it in my calculator, I'm going to get my approximate answer. I already know now this guy here is going to be approximate. Let's see what I get. Tell me what you get. Don't even try to think anything at a very deep level. Think of an angle at 50 degrees, think of a side of 20, think of a side of 10, and the missing components. Think about that picture. If you got this on an SAT test, you would have to explain why it's an error.
Is it a Pythagorean theorem?
There's no Pythagorean theorem. I need that for only right triangles. Give me anything you want.
Now I was going to say that the angle B is small. No, because the angle A is 50 degrees in this end, and then the angle B is bigger, and then it corresponds to 20. It makes sense. And it's not corresponding. Like the biggest, the biggest, the smallest, the smallest.
But I don't even know what they are.
That's what I was saying.
Yes, I don't even know. I can't come to that conclusion.
I was thinking.
Yeah. So let's actually think of those numbers. So that might be 50. It might be a little too low. I don't know. I can't do that. A little bit better. 50. And so Let's make this guy 20. So we'll call that 20. It'll be increments of 10, right? And so that guy over there is a 10. So when you did constructions, you took your compass and you did this, right? So all of that radii is a 10, right? All of those are 10. And so this is 50 degrees. This is control. I don't know how long this is, right? I know how long this is. I don't know how long this is. It could be this big, it could be this big. In fact, let me just do this. Tell me something. This side is 10. This is also controlled. It's 10. It might be here, it might be here, it might be here, because I don't know this angle measurement yet. Tell me something. Why do I get error? It'll never touch. How is that 10 supposed to touch that? It's 10. He's trying. I'm trying to get over there. I'm trying. I can't. Right? That's why you get an error. So can I solve this triangle? Oh, wait. It's not a triangle. Interesting. Lord help me, these just don't stop, do they? Lord help me. Infinite supply of these things. Let's do it again. All right. Well, I can't go find the third angle because I have two of them missing. Okay, so I'm going to start using my law of sines to solve this oblique triangle. My completed ratio is the a's, so sine of 35 degrees over 12. Oh, I don't know. I can't do the c's. I guess I have to pick the b's. Sine of capital B over 16. So I need to isolate sine of B. Sine of B, 16, sine of 35 degrees over 12. I'm going to have to do some inverse trig. And now I'm going to go grab my approximate answer. Hey. Oh wait, we're going to approximate to for degrees to the nearest whole number, whole degree. Do you get approximately 50 degrees?
Yes.
Fabulous, fabulous. I'm sorry, I'm doing inverse trig. Sine, I did the right one, but sine is actually positive in quadrant 1 and quadrant 2. So for that ratio, it could be 50 degrees, or what else could it be? 130, right? It could be 130. So, I'm sorry, wait, let me try that again. A, B, C, they gave me 35 degrees. We just said B was approximately 50. Well, duh, I can see that. And then, again, A, B, C, they gave me 35 degrees. You said the second one was what, 130? Could I make a second triangle with that?
Yes.
Ah. So this problem has two triangles, and you have to solve both of them. Aren't you so excited? Double the work. So this is for this triangle. Well, and I guess I better go draw my other one out. Find the measure of angle B, the measure of angle C, and side C for triangle number 2 and triangle number 1. Oh, yippee skippy. Oh, wait, and what was that one? I'm sorry, okay, wait. Let's just find it right now. If this one is 50, then you told me that this one here could be 130. So if this is 50, 50, and 35, that's 85 from 180, so it's approximately 95 for C, yeah? And so for this one here, 130 and 35, that's 165, so this one here is approximately 15. So now I have to go find side C here and side C here. I might as well finish this guy up. So again, these are the exact ones. I'm going to use A, sine of 35 degrees over 12. I have to find side C, so I got to use sine of angle C, and in this triangle, it's 95 degrees. Did you get this? And go grab me the other one. So, what I did is I gave you the law of sides. Number 1. Number 2, I just told you what solving an oblique triangle it is, and that's to find everything. And then I just gave you some givens. I gave you 3. You drew it out. You made your box of what you had to go find. And hopefully they gave you 2 angles. Find the third. Easier. But when did I have to check to see if there were 2 triangles or not? When did I do that? When they did not give me 2. They gave me 1, which means the next one I had to go find was through inverse trig. Inverse trig, because that ratio could be 2 different angles. So in inverse trig, I'm either going to get error, no triangle, or I'm going to get 1 triangle or 2 from inverse trig. But our first 2 problems where I gave you 2 angles and 1 side, we didn't run into that problem because there was no inverse trig. I immediately, first thing is found that third angle. Well, then there's no inverse trig. Then there's no 2 possible answers.